This is lesson 7 in the GCSE Force and Motion topic entitled Centre of Mass. During the course of today's lesson, you should understand what we mean by the term centre of mass, or COM for short, and secondly, determining practically the centre of mass of an object. Okay, for all objects then, their mass is spread out over the whole object. However, this isn't very useful to us as physicists. For example, if you're designing buildings that don't want to topple over in the wind, it's important where we know where this centre of mass is. This title, centre of mass, needs to go into your books, and all on this slide needs to be copied into your notes. So firstly, the centre of mass of an object is the point at which the mass may be thought to be concentrated. So that's a definition. If you're asked for what centre of mass means, that's what you would say. The point through which all the mass appears to act. Finding the centre of mass then, it can be easy and it can be difficult. So if you've got an object which has an irregular shape, a complicated shape like this here, it's relatively difficult to find where that centre of mass is, but we will be discussing how you do that a little bit later. If, however, you've got simple symmetrical objects, then the centre of mass can easily be found. All you simply do is you draw in a single line of symmetry. This for a circle, it's fairly straightforward, and you know that the centre of mass lies along that line of symmetry. If the object has a second line of symmetry, or even a third or fourth, draw them in, and the point at which they intersect is the centre of mass. So really easy method to determine the centre of mass for regular objects. Pause the video and make sure you've got that in your notes. Okay, let me take you through a few examples then. We said that it's fairly simple to work out the centre of mass of a symmetrical object. It's simply where the lines of symmetry intersect. So there we've got one line of symmetry. If I draw in a second one, then the centre of mass will be at that point there. Very easy, very straightforward. Let's change to a more complicated shape, like a square here. Same idea, one line of symmetry, two lines of symmetry, and the centre of mass will be there. What could go wrong? Nice and simple. Example 3, we do start to have problems here, because yes, we can draw in a line of symmetry like so, and we know that the COM, the centre of mass, is somewhere along there, but there is no obvious second line of symmetry there. So for more complex shapes, we can't actually determine the COM by this method. To get around this problem, we use a property common to all objects that are suspended. So if you suspend an object from a particular point, so we've got a stool here which is supported here, if you leave it for a short while, it'll stop moving about and come to rest. When this happens, the centre of mass will be directly below the point of suspension. So it's hung there, the centre of mass will be somewhere along that line there. Now, admittedly, this is 3D, we've been looking at 2D, but you could work this out in a similar way for 3D. When it's stationary like this, it's said to be in equilibrium. We've met that term before. As far as your course is concerned, you need to be able to describe a method by which we could determine the centre of gravity of an object. So the next slide, this one here, gives you a little run through of the methodology that you'd use. Okay, so if I take you through that, and as I say, this needs to be recorded in your notes then. The centre of mass irregular shape can be found by using the apparatus shown. So essentially you've got this irregular shape here, some kind of polygon, which is suspended from a kind of hook here. So you see these little holes here that go through there, and it's allowed to hang freely, it can move about. In front of it, you've got a little mass on a piece of string. That's what's called a plumb line. And if you allow that to settle down, that will give you a line under which it's suspended. Now, if you draw along that line, okay, record that on your piece of paper, or put a couple of crosses on it, first and then draw in the line in full later. That'd probably practically be better and easier to do. Then what you do now is you replace the hook in a different position. So you're rotating the object round again, and you do exactly the same. And you can see the picture here, the person's already done that twice, and there's got two other lines of points of suspension there, and you can see quite clearly that they all intersect at that one point there. So you would carry on doing that over and over again, and they should in theory all coincide at that same point. If you want to try this at home, you can do. You can test to see whether you've got the COM accurate by taking your shape made out of cardboard and just put your finger underneath where you think the COM is, and it should balance at that point. A nice short lesson, this one. So by means of review, you should know that the centre of mass is the point through which the entire mass of a body appears to act. For regular shapes, the centre of mass lies at the intersection of the lines of symmetry. For irregular shapes, the centre of mass lies directly below the point of suspension. If the body is suspended, easy for me to say, from another point, a second line of action can be found. The intersection of these two lines will give you the centre of mass. Okay, I'll see you in the next video.